Okay, we're going to do some work with confidence intervals and a mean. And basically, we're going to say, we're going to look at tuition costs. A lot of my students were concerned about social justice of people having access to college, and part of that is tuition costs. So we're saying that basically an organization collected data on the cost of attending college from 153 public four-year colleges. The sample mean was $24,061. Now, by the way, this included tuition, housing, meal. Tuition was about $9,410, housing, meals about $10,000, books about $1,300, transportation, etc. So the sample mean, 24,061. We have a sample standard deviation of $932. Calculate a 90% confidence interval for the cost of attending college. Okay, so this population standard deviation is unknown, so we're going to use the student's t distribution. And so for a 90% confidence interval about the mean with sigma unknown, this is our formula, x bar plus or minus t alpha over 2 times s over the square root of n. Okay, so our formula is x bar plus or minus t alpha over 2 times s over the square root of n, or the standard error. We know the sample mean is x bar, $24,061. We want to find next, we're going to add and subtract the critical value, critical t value here, not the critical z value. So for the critical t value, we need to know the degrees of freedom. That's n minus 1. If we have the degrees of freedom 131 minus 1, then our degrees of freedom are 130. The TI-84, to find the critical t value, you need not just the area left, but you also need degrees of freedom. So you do inverse t, area left, degrees of freedom. And I will show you for your t-table, you need degrees of freedom, and instead of area left, we're going to need area right. But that's no problem. For a 90% confidence interval, we have alpha over 2 in each tail. That's 10% over 2, or 0.05. So either way, area left of this t-value is the negative, we'll have 0.05, and that's the negative t-value. Area right of the t-value is 0.05, and that's the positive t-value. Okay, so on the calculator, TI-84, you go second, distribution, or VARS, and then you're going to select the inverse t. You're going to pick on area left and degrees of freedom. That will give you approximately negative 1.657. All right, if you are using the t chart, then we need degrees of freedom. Degrees of freedom was 130, so we'll go down to that row of 1 degrees of freedom equals 130. And now we're doing area right. We're doing the right side. So we go to the column of 0.05. We go to the row of 130, and we get our critical t value of 1.657. All right, so basically both of those manners told us our critical t value, which was negative 1.657 and positive 1.657. If I now plug in some of these values, I get x bar plus or minus the critical value times the standard deviation, the sample standard deviation, which was given on the first page, 932, over the square root of n. And I multiply all that out. The first part is the point estimate. The point estimate is sample. It's the sample. If I said approximately how much does it cost to go to college, a public in-state college, somebody could tell me approximately $24,061. And then because we only took a sample, we don't know the actual population college cost. We say, okay, well, give or take a little bit. So because we only asked 131 colleges, then that's plus or minus, let's say $135. So our our confidence interval, our 90% confidence interval, is approximately 23,926 to 24,196. We're 90% sure the true population cost, the cost of all of the population of the public and state colleges would be between 23,000 some and 24,000 some. Okay, so there's an easier way to do this on the TI-84. If you click on the button Stat, then click over to Tests, choose number 8 t-interval, you will input the mean, the standard deviation, the sample size, and the confidence level of 0.90, and it will tell you the confidence interval that way. All right, next I'll show you how to do that on Staccato. You're going to click on Statistics, Confidence Intervals, and population mean. I don't have the samples in a column, I have the summarized data. That was $932, the sample size was 131, that's N. The mean, 24,061. The standard deviation, 932. And if I know sigma, I would click that. Sigma is not known, so that's why it's using S, or the sample standard deviation. And so it knows now to do a t interval. I'm going to choose my confidence interval. By default, it's 95, but I want a 90% confidence interval. And I click OK. And I can see here it gives me 23,926 to 24,196, the same confidence interval that I got before.